You've built a Blazor WebAssembly app, connected it to IdentityServer, and added authentication with Microsoft Entra ID. Everything works. Feels secure, right? But here's the real question. Is it actually secure? Authentication is just the front door. What about the windows, the side gate, the garage left wide open? Blazor WebAssembly apps run entirely in the browser. That means your compiled .NET assemblies, your DLLs, are sent to the client. Anyone can open DevTools, download those files, and decompile them. And no, this isn't a bug. This is how WebAssembly works. But it does mean something critical. Your client-side logic is fully visible, so security decisions must be enforced on the back end. A real attacker doesn't click around like a user. They open DevTools, look at tokens, poke your API calls, and try to tamper with anything they can touch. If you don't test your app the same way, you're shipping with blind spots. That's where Stride comes in. Stride is a threat modeling framework from Microsoft. It helps you think about 6 different types of attacks. It stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Let's break these down with real-world examples, especially for Blazor. Spoofing happens when someone fakes an identity, usually by stealing or misusing authentication tokens. In Blazor, if you're storing tokens in local storage, they're vulnerable to JavaScript-based attacks like XSS. If someone grabs that token, they can impersonate the user. To prevent this, use short-lived tokens, store them securely, and never rely on client-side checks to authorize requests. Tampering happens when a user modifies data before it reaches your backend. Here, the attacker changes the user ID in the browser from their own to 999 using DevTools. If the backend doesn't verify that this user is allowed to access that ID, the attacker now sees someone else's data, maybe even an admin's. Never trust user input from the browser. Always validate identity and access rights server-side before returning sensitive data. Repudiation is when someone takes an action, deletes a record, triggers a sensitive API, and later claims, "That wasn't me." Without proper logging tied to user identity and timestamp, you can't prove otherwise. Always log key actions securely, and never rely only on client-side logs or console output. Next comes information disclosure. This is about giving away more than you should, like stack traces, debug info, or even secrets accidentally exposed in your Blazor DLLs. Anyone can decompile your WebAssembly app. If it includes sensitive logic or hard-coded API keys, they'll find it. Move secrets to the server. Treat the client like a display layer, not a vault. Denial of service, or DOS, is when someone floods your app with traffic until it slows down or crashes. This could be a login form spammed with requests, or a search feature abused in a loop. To defend against this, implement rate limiting, queuing, and timeouts. Never trust that every request comes from a friendly user. Elevation of privilege happens when someone with basic access manages to act like an admin. Maybe they change their JWT in DevTools to include a fake admin role. If your server doesn't double-check that claim, they're in. Always enforce permissions server-side. Never rely on claims passed from the browser. Testing is just as important as building. It's not enough to understand threats. You need to simulate them. These are just some of the tests we run to stay ahead of attackers. You don't need to run them all at once, but make testing part of your workflow. You don't need a full security audit to stay ahead of attacks. Before you launch a feature, just pause and ask, could someone spoof this? Could they tamper with it? Could they deny it later? Are we leaking data? Could this be abused or overloaded? And could someone escalate their privileges? Those 6 questions, that's Stride, and it only takes 5 minutes per feature. Blazor WebAssembly apps are modern and powerful, but their client-side nature means they're exposed. You can't stop people from seeing your code, but you can stop them from abusing it. Stride helps you think like an attacker, and when you think like one, you start building like a defender. In the next video, we'll take this a step further, running live tests using Postman and browser tools so you can simulate real attacks on your own app. If this helped you think differently about Blazor security, drop a like, subscribe, and leave a comment below. I read them all. See you in the next one, where we put this into action.